Okay, so yesterday we looked at the internal angles of triangles and quadrilaterals, and you remember that we worked out that the sum of the internal angles of a triangle was 180 degrees, and the sum of the internal angles of a quadrilateral was 360 degrees. Now, if we're looking at regular shapes, which we are here, so this is a regular polygon, sorry, a regular pentagon. What we mean by that is that they have, however many sides they have, those sides are equal, and because of that, are equal length, and because of that, the internal angles are all the same. So we could measure the internal angles of this pentagon, and we would find that at each vertex, the internal angles were identical. So there are essentially two ways of working out the sum of the internal angles, and I might show you the other way tomorrow, but the simplest way is to divide your shape, your polygon, into triangles. And this works for any regular polygon. You need to essentially start drawing triangles from one vertex down to two other vertices, so that we now have split that pentagon into three triangles. So a regular pentagon can be split into three triangles. You always start from one point, and there's lots of practice on this in the exercise this morning. So you split it into three triangles. Each triangle, you know the sum of their internal angles is 180 degrees. And therefore, as there are three of them, you can multiply 180 by 3, and that will give you 540 degrees, which represents the sum of the internal angles. And you will find, as you do the exercise, there is a pattern that emerges as you try different shapes. So hexagons and heptagons and octagons. See how you get on and see if you can spot the pattern. So this is what I call angles detective work. So this looks very difficult. We're trying to find this angle x here with no real knowledge of what it is. The only angle we have is that one of 62 degrees. So that may be useful, but there are other things that we need to be aware of. And I call this detective work because you have to look at all the information you've got. First of all, it tells you it's an isosceles triangle. ABC means ABC. So that triangle, although it's lying the wrong way up, it's isosceles. There's another clue that we covered yesterday. These things means that these two lines are the same length. And that means that those two angles are the same, the opposite angles. So this one will also be x here. That one will also be x. We know that BCD is a straight line. So if that's a straight line and this is 62 degrees, then we can work out what this angle here is. Okay, because this will be 180 minus 62, which is 118. Okay, so if we know that this angle here, I could redraw this for you. So now, if you prefer to see the triangle the right way up, it looks like this. Not to scale. But we know that this one is 118 degrees. And we know that these two, this one here and this one here, are going to be the same value. So now we've got to take 118 away from 180, which is 180 minus 118, which is 62. And therefore, each of these will be half of 62, because the whole lot's got to add up to 180. So half of 62 is 31 degrees. And the answer, therefore, is that x equals 31 degrees.